Hi, welcome back to your new lesson. As promised in a previous lesson, in this lesson, we are going to discuss about the exception handling, how ARM processor handle the exceptions. Moreover, we will see how it handles into the third section. But here we are going to see what are the exception handling techniques are available into our microcontroller. As previously, we had discussed that an exception is any condition that need to be halt the normal sequence execution of an instruction and the processor has to go somewhere else to handle that exception. Okay, and there are many examples such as if ARM core reset, then the processor has to reset the full system. The another instruction, let's say when an instruction fetch has occurred, but that instruction is undefined, or when instruction is being pre-fetched and the abort has occurred, or if data is being handled but the data abort has occurred. Okay, and of course the interrupt request type. So these type of the exception, and the most exception have an associated with the exception handler. So if any of these exception has occurred, then there is a exception handler. So you can ask, what is the exception handler? Exception handler is a kind of a function, you can say, in a C programming. Function in C programming. If we talk in C programming language, it's a kind of a function. That's when there is somewhere the exception handler for the data abort. You can name it actually, right? You can name it, let's say like this: the wired data underscore abort underscore exception underscore handler. Okay, and then you pass the processor state, and then finally you can write the function to handle this data abort exception. And similarly you can write a function for wired data, the pre-fetch abort, etc. Right? But the address of these function is defined by the vector table. Okay, so address of each of these function is defined by the vector table. So the vector table has a fixed address. It has a fixed address to serve the interrupt or exception. Okay, to serve the exception. So that is the vector table. Okay, perfect. And so once the processor has a vector table, and then the processor will be having its a memory address. Let's say we have 7 type of exception, and those exception are the reset. Okay, and then we have here undefined instruction. We are going to write that once again. And then we have a software interrupt, that is the SWI. And then here we have here pre-fetch abort, and then we have a data abort. After that we have IRQ and FIQ. Okay, and the address associated with these, let's say you can say it, this is the type of exception which is occurring here, and then here we have the address, the vector address. Okay, That's mean the address where microcontroller or ARM processor will take if this type of interrupt occurs or exception occurs. So for reset, it takes at the location of 0x00 or 00, you can say, right? Okay, so now on we are going to take only these last 4 digits, and for undefined it will take processor to 00 at a 04 address, and for SWI it will take processor at the 0x0008. Okay, and similarly for prefetch abort it will take processor to 000C address, and for data abort it will take it to 0x0010. Okay, and at the IRQ exception it will take processor to 0x00, and of course there would be the 40, let's say, and then 00 and 18, and then finally FIQ it has 0x001C. One thing you might have noticed here is that the address of next exception, that's into the vector table, is +4. Okay, it's always +4 here, you see, but here if you see it's the +8, right? So what happened here? So there is 2 location here, so there is one address in between, that is the 0x000014, which is reserved address. Okay, so which is reserved address. Okay, so the processor don't have any interrupt vector table for this address. So what happens, data abort goes from 10 to 13, and then from the 14 to 17 there is no vector table, there is no assigned exception for that address, and then finally the IRQ starts from 18, and then FIQ starts at 1C. Okay, right. So apart from this vector table, but when exception occurs, the processor also changes its mode. So if you have watched my previous lessons, you might have noticed that I had described there a mode of a processor. Okay, so there were 7 modes of the processor, and here we are going to discuss those modes and these exceptions, how these modes and exceptions are correlated with each other. So there are only 5 modes in which exception can occur, and we are going to discuss that 5 modes. Okay, so let's say here we have this, and now what happened, let's say here we have now 5 modes. So the first mode is undefined, and then we have IRQ mode. If you remember it, we had also FIQ mode, in which fast interrupt handle, this FIQ mode handles fast interrupt, and then we had abort mode, and then we had SVC mode, and apart from this we had system mode and the user mode. Okay, so these 2 modes are not included here while handling the exception and its associated mode. So there is only these 5 modes here. Okay, right. So once you have these 5 modes, then let's say here we have our exception, and these exceptions are of course 7 type of exception. once again I am going to write those exception there, or what I can do, I can take these exception from here to here itself directly, and then I can delete this. Yes, okay. So let's say here now we have an exception. Now once we have these exception, save an exception, and here is the modes. So here we have a mode, and this is a exception. Now we are going to match. If undefined exception occur, then it associated with this one. If FIQ occurred, then of course it is associated with FIQ. If IRQ occurred, then of course it is associated with IRQ. And if data abort occur, then it is associated with abort. And if prefetch abort occur, that is also associated with abort. Okay. And if reset and SWI occurred, if reset and SWI is occurred, that is related with the SVC, that is the supervisory mode, let's say. Okay. So what happens if FIQ exception occurred? The processor enters into the FIQ mode. If IRQ exception occurred, the processor enters into IRQ mode. And if data abort exception occurred or prefetch abort exception occurred, then the processor enters into the abort mode. And if SWI or the reset occurred, then the processor enters into the SVC mode. And if undefined occur, then the processor enters into undefined mode. So this is the relation between exception mode and the exception and in between the mode. And the user and the system, okay, the system and the user modes are the only two modes that are not entered by the corresponding these exception. In other words, what we can say here, to enter into these mode, user has to modify the CPSR. If you remember it, that's the current program status register. I'll show you how you can modify this CPSR with MRS and MSR instruction set. Okay, so the CPSR can be modified easily with the MRS and the MSR instruction set. So now the question you can ask me, what happened? Okay, so what happened when exception occur? So the processor do the first two things when exception occurred. In fact, the processor do the first four things when exception occurred. The first thing which processor do or the microcontroller do, it first saves the CPSR into SPSR. Okay, SPSR of exception mode. If you remember my previous tutorial, I had shown there that every mode has its own SPSR and the setup bank registered. Okay, if you might have remembered that. So every processor mode has its own SPSR. So once some exception occur, so the processor enters into that corresponding mode, and then it first stores the CPSR into the SPSR of that corresponding exception mode. And in the second step, it saves the PC, that's the program counter, to the link register, that's the LR, link register of the exception mode. Okay. of the exception mode, as these exception mode has its own link register. Okay, and then in the third step, what it do, it set the CPSR of to the exception mode. All right, what it do, it set the CPSR to the exception mode. Okay, that means it set the CPSR to the exception mode. If you might have remembered that the first 5 bits, okay, so the first 5 bit into the CPSR, which is ultimately the 32 bit long, so these first 5 bits define that what is the processor mode. Okay, so then it set the CPSR to the exception mode, and those exception mode can be set by setting these 5 bits. And after setting this CPSR, and then it set the PC to the address of the exception handler. PC to the address of exception handler. Now you might ask that what is the address of that exception, and that address comes from here, the vector table. Okay, so this is the vector table, and from here that exception address comes. Let's say if I say to you that undefined, okay, the undefined has occurred, so in this case the program counter will be loaded with the address of undefined, and the undefined address, if you remember, that was 0x0004. So this is the address of undefined. Okay, so this is how microcontroller work. And the one more thing which I would like to highlight here is that when exception occur, the ARM processor always switches to ARM state. Always switch to ARM state. So you might have remembered that we had discussed earlier the state. There were 2 states. The first one was the thumb state, and then we had here the ARM state, right? So when exception occurred, the microcontroller automatically changes its state to the ARM state. Okay, great. So now you might ask a question, what will happen if the 2 interrupt occur simultaneously? Let's say the prefetch abort and IRQ. Let's say this. Okay, so if these prefetch abort and the IRQ have occurred simultaneously, then what will happen at this stage? In fact, what will happen to all of these stages? That's mean which exception processor is going to serve first, whether the processor is going to serve first prefetch abort or it is going to first serve IRQ. So that is the question of the exception priority level. Okay, so that is the question of exception priority level. Which exception has what priority? This defines that which exception will be served first if 2 exceptions occurred simultaneously or 1 exception occurred after another. So it will be defined by the exception priority level. So this is all about in this video. In next video, we will discuss about the exception priority level, how the processor decides which exception has to handle first and which exception can be delayed. Okay, so stay tuned with this lecture series. Please do not forget to subscribe this channel so that you can get updates directly into your inbox. Bye bye, have a nice day.